Integration made simple. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll take another set of three questions where we are going to learn how do we do integration using the method of substitution. Well, this is our set 4 in which we have trigonometric functions. You need to decide which one should be substituted as e. You can pause the video, answer the question, and then look into my suggestions. Those of you who want to learn from me directly can send an email on globalmathinstitute at gmail.com. Let me also thank all the viewers and subscribers for supporting your channel. This is your channel. We solve your questions and provide you with quality solutions. Those of you who are contributing, I'm extremely grateful to you. Every dollar counts. You can always contact me on globalmathinstitute at gmail.com to work out how you can support regularly. You can also donate whenever you feel like. Let's get back to the solution of these questions one by one. As you know, this is the practice session. We've already done set 1, set 2, set 3, and we are now looking into the set 4. All these three questions will be solved in this particular video and the remaining in the following videos, followed by many more questions. So follow our playlist to learn effectively. So let's see. In the very first case, what should be the substitution? Well, sin x in the denominator is a good candidate for substituting. So we'll write u as sin x. And du will then be equal to derivative of sine is cosine x dx. Correct? So that substitution can help you solve the first question. For the second, the odd degree is for sine and the even for cosine. So we'll keep sine x dx aside, and so in this particular case, we are going to substitute u as cos x. In that case, du will be minus sine x dx. And in the third case, again, we have taken two different types of functions, cos and sine, and both degrees are odd. Now, in this particular case, you can assign anyone as u. So, u better to substitute for cosine, right? So, u will be equal to cos x and du will be minus sine x dx. So, with this substitution, you can actually solve the questions. So, I hope that's absolutely clear. So, you solve the questions, and here is my solution just to help you out. Right. So, integral of cos x by sin x, as I said, will substitute u equals to sin x. In that case, du will be equal to cos x dx. So, therefore, we can rewrite this integral, which could be written as you can see, we can write this as 1 over sine x, right? That is the first part. And the derivative of this, which is cos x dx. So clearly, when you see that a part of it is a function, the other part is its derivative, you can use the method of substitution. So that is the key. And now we can substitute and get our solution. So what we get here is integral of 1 over u and cos x dx is du. And clearly this integral is ln. And whenever you do ln, u has to be positive, correct? Plus constant c, since every constant will have derivative as 0. So it's a family of curve which we're looking at. Getting back to our main values, which is ln, and u is sine x. So absolute value of sine x plus c becomes the integral for this particular question. Is that clear to you? Perfect. So do not forget to place the absolute sign, that is a key, while learning this particular method. So I hope this concept is absolutely clear. Now let us move on to the next question. We have integral of cos square x sin x dx. So in this particular case, as we decided, we'll substitute u as cos x. So du is going to be minus sin x dx. So now we can rewrite the integral, which is cos square x sin x dx. You see, the integral part is now product of function and its derivative. Well, we do have a negative sign, so what we can do is we can substitute with a negative sign, right? This is for this negative sign. Cos x is u, so cos square x will be u square, and we have du. Makes sense, correct? So derivative will now be minus u to the power of 3 divided by 3 plus c, which is minus cos cube x, one third of this, right, plus c. So that becomes the integral of the given function. See how simple it is once you understand these strategies. Now let's take the last question out of this three, right? So we have cos to the power of 5x sin x dx. So in this case, let us substitute u as equal to cos x. In that case, derivative will be minus sin x dx. So making the substitution as we did last time, negative will come outside and we have u square, right? U to the power of 5 in this case, sin x dx is du. And we have a very similar result, which is negative u to the power of 6 divided by 6 plus c. Substituting u back as cos x, we get cos to the power of 6x plus c as our result. See how simple it becomes. So this set of three has been completed, and in the next set, we are going to look into the slightly more complicated examples which you can see here. I hope you understand these concepts. Feel free to write your comments and share your views, and keep on supporting your channel. Thanks for your support and all the best.